Now, as you can see this week, we now have these beautiful alum crystals, but how do we know if we made as much alum in the lab as possible? That's where we need to calculate the yield. The theoretical yield is how much alum we should have made, and we can calculate this based on the amount of aluminum foil that we started with. So we started with 1.008 grams of aluminum foil, which we're extending for our purposes to mean 1.008 grams of aluminum. Then, using the molar mass, we can see this mass is equal to 0.03736 moles of aluminum. Now that we have the moles of aluminum, we can go through the 4 reactions we performed in the lab and track the moles of aluminum we end up with using the stoichiometric coefficients. So you can see for the first reaction we ended up with 1 mole of aluminum as a product, then the same for the second reaction, same for the third, and same for the fourth. So we end up with 1 mole of aluminum for every mole of aluminum that we originally started with. Now in the final reaction with alum as its product, if you look at the alum molecule itself, for every 1 mole of aluminum there is 1 mole of potassium, 2 moles of sulfate, and 12 moles of water. Using these mole ratios and the molar masses of each of these molecules, we can add up the masses of each element to get the final theoretical mass of alum, which turned out to be 17.72 grams. We can then see how successful we were in making this 17.72 grams by calculating the percent yield, which is equal to the actual amount we measured divided by the ideal amount that we just calculated. This ended up being 71.11%. We fell short of the ideal amount, and there are several possible reasons for this. First, we assumed that the entire mass of the aluminum foil was the mass of aluminum, and therefore the moles of aluminum. But actually the foil contained impurities that took up some small amount of its mass. This could have inflated our theoretical value and given us a lower percent yield. We also couldn't guarantee that all of our reactants in each reaction were conveyed to products, when there may have been reverse reactions going on. And lastly, we carried out a series of filtrations during the lab, which could have made us lose some of our product from the end. All that being said, these are what the crystals look like this week. I've been able to grow 2 good-sized crystals, and I think this has something to do with where the alum solution is actually sitting in my room. It's been sitting on my windowsill, soaking up the sun, as well as the light from my desk lamp at night, which may be helping the solvent evaporate faster and therefore help the crystals grow faster.